This is a brief severe weather evaluation for December 16th, 2019. The Storm Prediction Center and the latest convective outlook has upgraded to a moderate risk across parts of Louisiana and into Mississippi. This is occurring as a surface low develops in northern Louisiana, right around in this region currently, and progresses to the northeast during the afternoon. Throughout the warm sector, we have a considerably unstable thermodynamic environment indicated here on the rapid refresh model by very large surface-based CAPE of 2,000 to 2,500 joules per kilogram. And part of that is going to be an unusual feature for this kind of setup: very steep mid-level lapse rates, 7 to 7.5 degrees Celsius per kilometer, owing to a differential advection situation within the vertical tropospheric column. That's going to lead to an environment that is more conducive to strong convective updrafts and severe weather, including large hail, which is kind of unusual for this kind of environment. While we have dry air advection going on aloft, at the surface we see dew points are already reaching and exceeding 60 degrees and could reach 70 degrees across parts of Louisiana and the Mississippi during the afternoon. We see also LCL heights, due to the very moist air mass, are going to be quite low, around 500 meters, and going along with that, LFC heights are going to be very low too, below 1,000 meters, and that's going to lead to LCL LFCRH that is exceeding 90% across Louisiana and spreading into Mississippi during the afternoon. That's going to lead to low cloud bases, but also, looking at the wind shear environment, we have strong effective bulk shear of 50 to 60 knots moving through most of this area here that's in the moderate risk. And that's going to be owing to this significant wave aloft as depicted here over the Central Plains and into the Midwest. Now, the most active weather is going to be in association with the strong flow that is occurring with this, and if we track the path of the surface low this afternoon, we have this whole area here that's in the warm sector, and as you see, that coincides with strong flow aloft and also what appears to be possibly a convergent jet stream flow situation, with one branch here and another branch coming in right here. It's going to lead to more efficient upper level dynamics, and one feature that is interesting to look at in this scenario, depicted by the models, and depicted very well by the models, vorticity advection, positive vorticity advection moving through parts of the Ozarks, deep south area, spreading up into the Ohio Valley. So although this is not a extremely sharp vorticity maximum, it is leading to PVA downstream, which is increasing the upper level dynamics and increasing the severe weather situation. Looking at a NAM forecast sounding, we'll notice a few things. Number one, the differential advection situation with somewhat dry air aloft and moisture advection in the low levels. But a really important thing to note too that is given by this sounding is that the entire effective inflow layer and boundary layer is characterized by high relative humidity. That's going to lead to low cloud bases and more effective tornadogenesis. With the amplification of low-level flow and backing of low-level flow in vicinity of the surface cyclone this afternoon, we expect large hodographs to be developing between 0 and 3 kilometers. That's going to lead to high storm relative velocity, which is given by the rapid refresh model here. Effective SRH of 300 plus as we go from Louisiana into Mississippi during the afternoon, which coinciding with the unusually unstable thermodynamic environment, that positive area there that I can't draw, that is leading to an environment that could produce numerous severe thunderstorms, some potentially quite damaging, including strong tornadoes and very strong wind gusts. The composite indices down here are well within the parameter space for a severe weather event and potentially significant severe weather. So what we're going to be looking at now is the HREF ensemble, the HREF version 2. First looking at the HRRR, which I'm going to be looking at mainly as the one right now, and we see what one could probably expect from such a setup: a differential convective mode, or a mixed convective mode situation here, where we have linear segments primarily along. I wish I could work any of this. A differential convective situation with primarily linear segments along the boundary, the approaching cold front, and what the moderate risk was issued for: supercells, discrete structures ahead of the line, which would be quite likely given the environment that is not only favorable for significant severe weather, but also the vorticity advection aloft and the lifting that it brings ahead of the front. That could lead to supercells downstream over parts of Louisiana and Mississippi, but linear segments will also be capable of producing widespread wind damage in addition to QLCS tornadoes. This has been a brief severe weather evaluation for December 16, 2019.